Now I will give you some example related to chapter 4 and the common mistakes the student do in chapter 4, chemical formula and equation. Let's see this question. The ionic half equation for the formation of oxygen during the electrolysis of aluminium oxide is shown. What are the values of x and y? Most of the students are very good in balancing the equation. They know that two oxygen are present here. So here we have only one, so it should be 2. Okay, but the common mistake the students usually do is, so these two options can be right. So the common mistake the students usually do, they forget to multiply this electronic, the oxidation number with the coefficient. So 2 into 2 is 4. So your answer should be 4 electrons. It should not be 2. They think that, okay, we have 2 oxygen, so it means it should be 2 electrons. No. If you see, one oxygen has 2 oxidation state. It means it is gaining 2 electrons here, right? So if it will lose 2 electrons. One oxygen will lose 2 electrons. But here we have 2 oxygens, so it will lose 4 electrons. So whenever you are balancing the equation, don't forget to see the oxidation state and multiply with the coefficient so you can get the exact number of the electron. So option D is the right option here. Let's see this question. This question is very important. Sometimes when the students are making the formula, for them it is very easy. They just cross multiply. For example, sodium oxidation is plus, and then if you see the oxidation state of hydroxide ion, it is -1. So they just cross multiply these their oxidation state, and they can easily guess the formula, right? NaOH. Or I can give you another example. For example, we have calcium chloride, CaCl2. How they can get this formula? Calcium has a +2 oxidation state. Chlorine has -1, right? They will cross these oxidation state, and then Ca will be 1 and Cl will be 2, right? So that is how they can make their formula, the molecular formula they can easily make for the covalent compounds. But when there are more than 2 elements present in a compound, how you can make the molecular formula? Like in this question, they have given you 3 elements now, and how you will make the molecular formula, that is the most trickiest question. So for that purpose, you don't have to write like this. You cannot cross multiply the 2 elements, because now we have 3 elements. So for that purpose, you have to remember that overall charge on a compound is always 0. So you have to try the oxidation state that the overall answer becomes 0. Okay, so let's see now one by one. We have 3 elements present, and each of them has different oxidation state. Okay, we have 2 different ions and 1 oxygen. If you see, one of them is negative, has a negative oxidation state, and the other 2 has the positive one. So it means the positive number should be equal to negative, so your answer becomes 0. So if you see, Fe is 2 plus, Fe is 3, this one is 3 plus, and then we have O2 negative. So how many positive charge we have? We have 5 as a positive charge, right? And how many oxygen we have here now? Only we have -2 charge. So we have to balance this +8 or -2. We cannot make it +2, right? So we have to make it -5, but it is not possible because this is an odd number. We cannot change it. So what will be the right option to do? If you see over here, there are 2 different ions. Okay, they are not the same ions. You cannot say they are same iron because they both are iron. No, they are 2 different. So now you have to treat them differently. How you will treat them? You can see which one is an odd number. Try to make that even. Okay, so which one is the odd number? This one, Fe3 plus, is an odd number. So try to make it even. So what I can do, I can make it 2Fe. So when I will make it 2Fe, now the charge will be +6, right? 2Fe will have a charge of, you can just write +3, but it will become +6, okay? So it has a +6 charge. What about this one? It is still 1, so its charge is +2. So now we have 8. Can I make this one 8? Yes, now it is easy. I can make it 8. -2, how many oxygen I need to make it 8? Just 4 oxygen, right? So then it will become -8. So it means I need 4 oxygen. And how many iron I need? I need 2 these iron and 1 this iron. So total 3 iron I need. So now the formula is Fe3O4. Okay, so that is the right option. You can choose how you will decide. You can decide by making the compound overall charge 0. So it will be helpful for you to make the formula. So option D is the correct option. Let's see another example. This is also another example, and we have how many ions in this one? We can see sodium ions. This is the same like the previous question. Okay, sodium ions we have oxygen ions, and we have chromium ions. Again, we have three ions over here. So you cannot decide that what will be the to the cross multiplication. Okay, you cannot decide the formula through cross multiplication. So this is how you will do. They already have given you the formula, and they are asking you now what is the oxidation state of chromium in this salt. So if you see, we have Na2, Cr2, and O is 7. So how many, what is the oxidation state of oxygen? Of course, it's -2. So -2 into 7 is equal to 14, right? Your answer should be 0 at the end. If this one is -14, then it means this should be +14, because both of them are metals, and metals always have a positive charge, right? So sodium, how many sodium we have? 2, and one sodium has an oxidation state of +1. Why? Because it's belong to group 1. So group 1 means it has the oxidation state of +1. So now we have 2 sodium. So this is +2, right? So how many left? We are left with +2, and this is -14. So it means chromium is how much? Chromium is +12, right? So now the oxidation state of chromium is +12. But if you look at here, the chromium are 2. So it means now total is 12, but each one of this is 6. So the chromium oxidation state is 6, right? And when you have 2 chromium, it will become 12. So 14, +14 and -14 will cancel each other, and you will get overall charge 0. So that's why the oxidation state of chromium in this salt is +6. Don't get confused. Don't choose the answer +12, because you can see over here clearly in the formula that we have 2 chromium. So each chromium has an oxidation state of +6. Okay, same is like for oxygen. You cannot say the oxidation state of oxygen is -14. It is actually -2, right? But we have 7 oxygen, so that's why the total is -14. So option C is the right option. So this is, I think now this is clear to you how you can make the molecular formula, or how you can interpret the oxidation state. If the formulas are bigger, they don't have 2 elements, they have more than 2 elements, then how you can calculate? You can easily calculate by finding the total mass, total oxidation state should be 0. Okay, for a compound, then you will easily find the oxidation state of the elements present in that compound. Let's see another question. A compound contains 24 gram of carbon and 4 gram of hydrogen. What is the empirical formula of the compound? Okay, so most of the students, what they do a mistake. They just cross multiply this one. They think 4 gram is hydrogen. So if 4 6 are 24, so it what will be happen? The carbon will be 6 and hydrogen will be 1. So they usually choose this formula, which is wrong. Empirical formula will always be decided by the mole number, okay? The mole number actually decided the formula. So you have to calculate the moles of these carbon and hydrogen. Let's find the moles, and the formula for the mole is mass given divided by molar mass. This is the first formula for the moles. We have 3 different types of the moles formula, but this is the common formula that is used, because we have given the mass is given in the grams, right? So this one will be the mass. We can just use 4 gram of hydrogen. And what is the molar mass? You can just look at your periodic table. It is 1 gram. So the moles of hydrogen is how much? Now 4. So hydrogen is 4. This is what you will get. What about carbon? Carbon is 24, and if you see the mass of the carbon in the periodic table, it is 12. So it is 2. So it means you have 2 carbon, right? This is the molecular formula of the compound. So what the students do usually, even if they know the mole ratio, how to calculate the mole, they will choose the option C. They think that C2H4 is the right answer, but it's wrong. They are not asking about the molecular formula. They are asking about empirical formula. So what does it mean? Empirical formula is the shortest, simplest ratio of the elements present in a compound. So you have to make it more simple. That is CH2, right? So CH2 is the right answer for this question. So B is the right option.